You know that every rational number can be written in the form a by b, where a and b are integers and b is not equal to 0. You have also learnt that the decimal representation of rational numbers is either terminating or non-terminating and repeating, and the division process is used for finding this form. How do we recognize whether a given rational number will have a terminating or a non-terminating and repeating decimal representation? Observe the decimal representation of these rational numbers. 5 divided by 8 equals 0.625. 2 divided by 7 equals 0.285714. 285714 being repeated. 8 divided by 15 equals 0.533333. 3 being repeated. 32 divided by 125 equals 0.256. 19 divided by 20 equals 0.95. 23 divided by 35 equals 0.6571428. 6571428 being repeated. Let us place them in a table. Notice that the decimal form of the rational numbers in the left column is terminating, while the decimal form of the rational number in the right column is non-terminating and repeating. To begin with, let us look at the rational numbers in the first column. Let us write the prime factorization of each of the denominators. Observe that the prime factors of the denominators are only 2 or 5 or both. In general form, this result can be stated as: if x is a rational number whose decimal expansion terminates, then x can be written in the form p by q, where p and q are co-primes, and the prime factorization of q is of the form 2 to the power of n multiplied by 5 to the power of m, where n and m are non-negative integers. Do you think the reverse of this statement holds true? Let us check what happens if we have a rational number of the form p by q and q has a prime factorization of the form 2 raised to the power of n multiplied by 5 raised to the power of m. Will p by q have a terminating decimal form? 16 by 50 has a denominator whose prime factorization is 2 into 5 square. You can see that the decimal representation of this rational number is finite. Look at another example. 5 by 8 has a denominator whose prime factorization is 2 cube. The decimal representation of this rational number is finite. Thus, we can see that any rational number of the form p by q, where q has a prime factorization of the form 2 raised to the power of n multiplied by 5 raised to the power of m, where n and m are non-negative integers, will have a terminating decimal form. Let's take a look at the rational numbers in the second column of this table now. We will write the prime factorization of each of the denominators. Do you observe that none of the divisors have a decimal representation of the form 2 to the power of n multiplied by 5 to the power of m? In other words, the prime factorization does not contain only 2 or only 5 or a combination of only 2 and 5 as prime factors. In general form, this result can be stated as a rational number p by q whose denominator q is not of the form 2 raised to the power of n multiplied by 5 to the power of m, where n and m are non-negative integers, will have a non-terminating and repeating decimal representation. You do not need to perform long division to check if a rational number will have a terminating decimal expansion or a non-terminating repeating decimal expansion. All you need to do is check if the denominator of the rational number is of the form 2 to the power of n multiplied by 5 to the power of m.